Hi everybody, my name is Larry Owens, and today we're here at Calhoun Community College in the CNC lab, and today we're going to use the ST10 and we're going to turn threads. But we're not going to turn normal threads, we're going to do a multi-lead or multi-start thread. In this case, we're going to do a 4-start thread on a 1-inch diameter shaft, and it's going to have a 1/4 inch lead and a 16 pitch size, and we're going to use the G76 can cycle to make our threads. Now, a normal G76 can cycle, you just specify the X, the Z, the K height, your depth of cut, and your feed, and let it rip, and you can make single lead threads all day long. Normal, just 1 lead threads. But today, because we're doing a 4-lead thread, we've got to add another word to the sentence. In this case, we're going to add the Q word. And what the Q word is going to do for us is it's going to specify the start angle of our thread. So in this case, we're going to use 360, 270, 180, and 90 degrees. But to specify that so that the Haas understands it, we need to add 3 more zeros after each of those numbers to represent the decimal place. Now, we don't use decimal points because it doesn't like that. So for 360, it's going to be 360,000, 270s, 270,000, and so on. Once we specify that, that's going to know where each of the leads going to start. And because we're doing 4 lead threads, we're going to need to do a quicker pitch, and in this case we're using a 1/4 inch pitch for each lead, which we'll just specify 0.25 in our feed word. And then in our K height, we're going to use the K height number that we would use for a normal 16 pitch thread. And also for our X, we would take our major diameter, which is 1 inch, and we take our K height, we double it and subtract it from that 1 inch, and that would give us our X diameter for the finished diameter, the minor diameter of the thread. So what we'll do is we'll take our workpiece, we'll chuck it up in the lathe. I'm going to take and I'm going to put a little dicom on the workpiece after I turn the profile, and what that's going to do is going to give us a little contrast as we're threading. And so with my program, I've stopped it for about 4 seconds between each of the leads of the thread, and I've also slowed down the rapids so that you can see kind of what's going on. It doesn't happen in a blur, and I'm using 100 RPMs on the spindle. So what we'll do is we'll take you inside, you'll get to see the threads cut, and when we get it done, hopefully everything will work out and we'll see a nice finished product. now for the moment of truth. There we go. Nice set of threads. Slides right on, right off. Nice smooth threads. Gotta love it when a program comes together. Hi guys, we're back from inside the machine. As you saw, we stuck the nut on it just to, see that we could do it, and I knew it'd work because, well, hey, you can't get anything in just one take. So I've done it a couple of times, and I've also got a couple of test nuts just to make sure it works. So as you saw during the threading operation, each of those leads are put in one at a time, and they, just like normal threads, it just feeds faster. You can see as you spin it up and down the shaft, it moves up and down the shaft quite rapidly with just minimal turns. And that's the purpose of multi-lead threads. So I hope you enjoyed my little video here and the inside workings of the machine. If you have any questions or comments, go ahead, feel free to make a little comment to it. And again, I hope you enjoyed the video, and look forward to doing more videos with you. Thanks again for watching.